Welcome to everyone. In previous class, we have discussing on optical actives. Like if SN axis is present, then that molecules are optical inactives, and if SN axis is absent, then that molecules are optical active. If present, then optical inactive. If absent, then optical active. Also, we have discussed that dipole moments. That some point groups shows dipole moments, and some point groups do not show dipole moments. Like CS, CI, and CN or CNB, this type of point groups is present, then that molecules do not show the dipole moments. Okay? Other than that, point groups show the dipole moments, like if have the SN axis, or if have the more than CN axis, or if have the symmetry elements like CI, like that center of symmetry is there, then that type of group shows the dipole moments. Also, we have maximum completed about of point groups, how to find point groups, all these things. So today we mainly discuss about the some examples of point groups. So we will solve some examples of point groups, and we will discuss the elements, what are the elements that contains a point group. So basically today class is we discuss the examples. So let me, so if you take the examples, like we have discussed that trigonal planar molecules. Let's discuss about trigonal planar. So this type of molecules, let's say if we say that any B here A, so this type of molecules, that is trigonal planar. We says that, or we can discuss some triangles type molecules first. Okay, so let's say any molecules is like this. It means that same molecules here, same molecules is present. For this, C3 axis is present, first E is present, that is E is present, plus C3 is present, and plus if you like here, then this is the planar molecule, so sigma H is present because C3H, this point directions from above, C3 axis is coming, and planar is on the board, so sigma H is present. And we can see that C2 axis also present, so if 1 6, then and C2 is present, and also that sigma B and sigma B is present. So this type of molecule says that sigma H is present and C3 is present, then there must be S3 also present. So this type of point groups lies C3 perpendicular to 3 C2 means D is there, so D, and principal is 3, principal axis is 3 here, C3, so D3, and H is there, so this is the D3H point groups. So now that another type molecules, like if we have this type of molecules, so here that what things are present here. If he says that here that C4 is present, first E is present, C4, then we can see that C2 is also present, like this, C2, so 1 C2, then 4 C2, and then also that 4 sigma B is present. And note that if Cn, then N C2 or no C2, similarly Cn, then N sigma B or no sigma B. This we are discussing from the very beginning classes. We have discussing this, and another things point you should note that Cn and Nc2 are perpendicular to each other. Cn perpendicular to Nc2. Sorry, I should not write here. This Cn this Cn, and for this I will write here this Cn is there, then what that n C2 is there or no C2 is there. Similarly Cn is there, then n sigma b is there or no sigma b is there, and the what that Cn perpendicular to nC2 and Cn parallel to n sigma b. Okay, so these things we have to note that Cn is that for the axis case this is perpendicular, and whenever we are talking about a sigma as that is planar symmetry, then they are parallel. The principal axis and n sigma b is parallel, because if this is perpendicular, then there must be Sn axis and all these things here. Although here sigma h is also present, but that whenever we are talking about these things, on that case this is parallel to this. Okay, so for these molecules sigma h is also present. Let's say this is for sigma b, and but this for sigma b is parallel to Cn. This n sigma b is always parallel to Cn, and this Cn is perpendicular to nC2. But now here C4 is also present, for C2 is also present, and for sigma b also present. This C2 is perpendicular to C4 and this is parallel to C4. Also here that C4 is coming out from the board, and that here also that plane is there, that so this plane that sorry, this molecular planes, this cutting all the molecules, that and this C4 is perpendicular, so here molecular plane is sigma h, so sigma h is also present, and if sigma h is present and C4 is present, then there must be S4 is present. So this type of point groups, mean your recurrence C4 is there, or C2 is there, means D4 is there and sigma h is there, then that will be D4H. So this point group is D4H. Okay, so similarly, like if you draw the molecules like these molecules, this type of molecules, here also you will see that C5 is there. Okay, C5 is there, obviously C2 is there, then 5C2 will be there, and obviously 5 sigma b is there, and what thing sigma h will be there, the molecular planes here, and C5 is coming out from the board, so this and this are perpendicular. Like say this, let's say this is our this molecules, then that so this molecules, now that plane is passing all the molecules cutting, so this planes, then C4 is coming this direction, so they are perpendicular, so sigma h is also present. So what, and sigma h is there and C5 is there, then there must be S5. So here you see that this and this shows that D is there and this is there, then D or sorry D5H. Okay, so this molecules has D5H. Similarly, we have discussed about that benzene molecules we have discussed. So here what C6 is there, E is there, and C2 is also there, so 6 C2 is there, 6 sigma b is there, and also this is the planar molecule, so C6 is this, then molecular plane is this, so this is perpendicular to principal axis, so sigma h is also there. So if this amount of elements, and also S6 is there, because this is there and sigma is there, means S6 is must be there. For Sn, what things are needed? Cn is needed, another is sigma h is needed. So this is there, then S6 is there. So these groups lies in but D, this C6 and C6 and C62 perpendicular means D6 and H is there, so D6H. So these are the some point groups. And now let's discuss more on, let's say that H2O2 molecules. So this actually makes a lot of confuse to us. So whenever you say that H2O2, this is exist in cis form also, this exists in trans form also, this also exists, really exists in open book form. So in cis forms we can say that like this oxygen oxygen, cis is this. Okay, so in this case we can say that C2 is there and C2 is there, E is there, sorry, E is there plus C2 is there plus sigma B also there. If you add these molecules, then sigma B is there. No, because this will reflect to this C2. Yes, 2 sigma B is also, sigma B is there. One is molecular sigma B, another is 1 sigma B, it cutting to this direction. So 2 sigma B is there. So C2E means Cn is there, means if we get 1 sigma B, then there must be 2 sigma B. So 2 sigma B is there. So this group is C2B point groups. Now if I talk about the trans, then this molecules and this molecules. Here if you look here, then what that if I rotate these molecules like this, then C2 is there. Okay, so if you visualize it, then C2 is there and E is there, C2 is there, and since here to here and here is the I is also there. I is also there in this molecules, because from here if I go here, then here go, here I go, here I go, I is there. It means, and another things, what things is there, that if you look here, then sigma B will be not present, because if I do it, then this will reflect here. So C2 and sigma H is present. Why? Because this principal axis C2 and the sigma, which is molecular, so that is perpendicular to I principal axis, so sigma is there. So this point group will become C2H. And if I talk about all the open book structures will be like this. So like this, or we can draw so in these molecules, if we see that, then here if we rotate by, then C2 is there, so E is there, C2 is there, and any others, I think this much, so this is C2. Okay, so note that this is actually in exams, this is H2O2 is given simply, then always assume that this is open book, this because this is actually really exist, and it mentioned that this is trans, then you will do this. If cis, then you will do this. So in cis, this is C2B point groups, in trans this is C2H point groups, and in open book in real this is C2 point groups. Okay, so next we will look on trigonal planar. So for trigonal planar, so this also we discuss the same things like B, H, H and H. So for these point groups, so if I look that this we already discussed, that here C3 is present, E, C3, and also here sigma H is present, here 3C2, this already we discussed, 3C2, T sigma B, and S3 also present, and this point group lies in D3H point groups. Okay, so this we already discussed, because this principal axis C3 and C3 is this, and sigma H is planar molecular, sigma H is molecular plane. Okay, so and C3 is coming to the means from the boards, means this is suppose this is molecular pin and C3 is coming this direction, so sigma H is also there, so this point group lies in D3H point groups. Now what I do that if I replace the molecules, so now what I am going to do is that here let's say let us discuss this is suppose A and A, then this is also D3H point groups. Now what I will do, B, here I will write A, here A, now here I will do the C, then what will be the point groups? So another things we have to note that, so this form or this C, here A, here A, this form here if I write A, write C, here I write A. So this A1, this is 2. These three structures are same conformations. It says that what I say that two terms you have to remember. One is conformations. Conformations means that rotate the molecules without breaking the atoms. Means if you rotate like this, then this is the conformations. Conformations means movement of molecule without breaking atoms. Without breaking atom in the molecule. So without any break, if you move, then that are called this conformation. So here C I move here, so here I am moving the C, so here I am moving C without any breaking, simply I am moving. So these all are in conformations. And another term is configurations. What are the configurations? That movement of molecule by breaking the atoms in molecule. So if that conformations you are doing, that the point group will remain same. So if you are doing the conformation, then point group remain same. But if you are doing configuration, then point groups change. This what it means, that if you do the configuration, then point group get changed. So this here what are doing the conformations we are doing, so configure that point group will not change. Okay, so here the structures I will write down, that I will change that D here let's say A, this is C. So in this three structure, let's say here the point groups is, so this point group is what are the elements are here. So if I drew the here, then if I pass this axis, so previously this point group was D3H. Now I replace one atoms. So after replacement, what happened, that C3 is not present, and now what is present, that C2 is present, and here this is C2, and if C2 is present and also 2 sigma B is present, So this point group is, and whether sigma H is present? No, sigma H is not present. So this point group is C2b, C2b. So this also should be C2b, and this also should be C2b, because we did the conformations. If the movements of molecules happened without breaking the atoms, then that case the point group remains same. Okay, so we can move the molecules in different orientations, then also the point groups of the atoms remain as it is. So we can move the molecules and check that in which orientations that is clearly visible to us without breaking the atoms. Means that should be a conformations, not configurations. If we break the bonds, then point group will change. Now next, so previously how many atoms we have changed? What first case, that pool are A. Now on this case D3H point groups. If I replace one atom, then that change to C2B point groups. Now if I replace two atoms, let's say B, A. Oh, this is same point groups. So this is as it is. So if I replace with another point groups, let's say D. So in this case, E is present, and what things are present here? That this is a planar molecule, so sigma is present, molecular plane is present. So only this is present because all the atoms are different. So this is belongs to CS point groups. Okay, so this type the point groups. Now we will look tetrahedral. Tetrahedral. So we know that tetrahedral means that groups A, let's say B, let's say this is also B, and let's say B, let's say this is the B molecules. This is let's say that CH4 type molecules. So here the point group is tetrahedral. Point group is tetrahedral, that is highly symmetric molecules we have says. Okay, now if I replace the one atoms, if I replace one atoms, let's say A, this is B. Now I replace that this is B, this is B, and now I will say this is C. Then what is the point groups of these molecules? So if we look at, then what things has absent, that previously in this molecule point principal axis was C4 was there. So here C4 is present. So since this also I can say that if I take C above, then I can write this. If I rotate, that can be easily visualized, and by rotating without breaking, then the point will remain as it is. So I'll write C here, and this B is comes to this here B, and here also B, and here also B. Okay, so now these molecules, that how it looks, let's say one molecule is this directions, one molecule is front, and one is front, another is back. So this black one is back, and sorry, this black one is back, and this is front. Okay, now one is in the plane, this is in the plane, and this is in the front, and this I can do some other. So this black one, so this blue one is in the fronts, and this is in plane, and this is back. Okay, so now what I do, I should get pen, then it's good. Okay. So see that this is front to you, this is front, this is in plane, and this black is back, and this is above. Okay. So now what I say that what is there? We have that this is different and this these things are same. So if I put it, just a minute. So let's say that uh, one molecule is different, above is different, and these three are same. If we look it, then we see that uh, one is front to front, and one is in the planes, and one is in back, and this is different. So these three are same. So if I search for this, what are the point groups? So if I pass the planes, if I pass any axis of symmetries by coming to this different molecules, this is red, this is different, and these three are same. So if I pass the planes coming to this different molecule that is in the red side, and if I rotate, then this will rotate. So C3 axis is present here. So here C3 is present, E is present, first E is present, then C3 is present. After that, what we see here, another one, I can pass that this. So can I pass the planes cutting this one and this one, and if this so is there C2? So no, C2 is not there, because these molecules, then if I rotate, then 3 are there, so C2 is not here. So C2 is not present, C2 is not present, and sigma B is present. Yes, because if I pass that planes, this cutting to this and this, then this two will reflect, this two will get reflected. If I cut the molecules here and here, then this two will get reflected, means sigma B is there, and one sigma B is there, then 3 sigma B is there. Okay, so now the what is the point? Sigma H is there here, sigma H, any chance? So C3 is coming to this, so sigma H should be here, but here no molecules is there, so sigma H is absent. So sigma H is absent. So no S3, no S3 is not present because sigma H is absent. So what things are there in these molecules? Then we have E, we have C3, we have 3 sigma b. So what are the point groups? That is C3b. Okay, so previously that is TT point groups, now it's changed to C3b point groups if we replace one atoms. So again, if I replace two atoms, then what will happen? Okay, so here I want to replace two atoms. So I will replace two atoms. Then let's say A. This is B. I want to replace this one C, and this one also I want to replace. Let's say D. Different molecules I search, and this is D, and this is B. So here what axis is present? So see that two are same and two are different. It means one is front and one is back. So two same and one is front and one is back, and one is above, means, and the one and two are in plane. Okay, so let's say two are in plane. So you see these are in the plane, and one is front to you, one is front, another is back, and other is, these are in the plane. So here what type of axis is there? You can see that these are in the planes and these are same, and one front, other back. Okay, so this is the structure of the molecules. Then what are the axes is present here? So can I pass C2 axis? So if I pass the C2 axis, then let's search. If I pass the C2 axis, because these are the same, so I can pass the C2 axis. Then in place of atoms will come, because if I pass the C2 axis here, if I pass the C2 axis, then what happened? This will get replaced, and these are the same. This is D and this is D. So this and this will get, and this get replaced. So C2 axis is present here. So E is present plus C2 is present, and what things are present? Sigma B. Any chance? Sigma B? Yes, sigma B is present. So 2 sigma B. So this is point groups of C2B. Okay, because sigma H is not present in this case. And now if I replace, so first this is whenever without any replacement, that is tetrahedral. And if I replace one atoms, then C3B. And if I replace two atoms, then C2B. Now if I make all are different, let's say A, B, C, D, and E. Then what will the structures? So since all are different, and this is also not in a plane, because one is front, one is back, so only E is present. In this case, that point group is C1. And let's say if A, B, and let's say C, and D, and let's say this is D. On that case, what things are present? So in this case, E is present and sigma is present. Let's see these molecules. Let's say front and back are same. Okay, this is front and this is back. These are same, and these are different. These are different. This and these are different. Okay, so one is front to you, another is back, front and back, and these are different. So any axis is present? Yes, if I cut the planes cutting to this and this, then this will reflect to this. So what is sigma B is also sigma is there. So point group H, if sigma is there, then there is CS. So CS point groups will be present. Okay. So next we will discuss on next structures we will discuss about square planar. Okay, so we will discuss about square planar. Discuss about the square planar. Then what is that we have discussed this one. So this is having C4 and for C2 and for sigma B and S4 and sigma H is present this molecules. Okay, so this is definitely D4H point groups. Now, so these molecules also we can draw like this. Let's search here any molecules. Okay, so here let's say B, 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 B. That is AV4 type molecules. Okay, so in this type molecules, the point group is D4H if the structure is square planar. Now, what I do that I will replace the atoms. Now, let's say that A, here I put B, I will put B and C, here let's say B. So one atom I replace. Then what are the point groups here? So here it looks, this is, if you just change, then while changing the orientation group, the point group will not change. So what I'll do is that if you look in different orientations, let's say I look this here, this amount of movement I will do, and let's say A is here, C is here, and here B. So this can be look. So if you orientation, the point group will not change. So if you move without breaking, then point group will not change. So this point group and this point group is same. So I just change the orientation. I change the shape so that I can easily visualize it. So here you see that if I pass that axis passing through C3, then this point group H, this is actually how it looks. This is actually looks like these molecules. These three molecules, three same, and one is coming from here. So one is back, one is front, one is back, and one is in plane. So if I pass the axis passing through this and coming down to this, so this is C3 axis is present. So this is actually which looks A. So one is C, and one is in front, one is in back, another is in plane. So this is similar to like NH3 molecules. So here what C3 is present, first E is present, then C3, then sigma B is present. Okay, so here if I cut this and passing the plane this and this, then if I pass, then this and this get reflected if I pass the plane by using this and this front one. By using this and this one, if I pass the plane, then this and this get reflected. So sigma B is also there, and if C3 is there, 3 sigma B is there. So this is the point group C3b, and this is same as NH3. NH3 also have the C3b point groups. So this is square planar, which is D4H point groups, that's changed to C3b. I think this is not able to looking there. So I will do another. So here, what things are there? C3 is there, plus what is there? 3 sigma B is present, and also E is there. So this is the point group of C3b point groups, and this is equal to NH3 type molecules. Okay, so if no replacement all are same, On that case, point group is D for H. And if I replace one atoms, this point group changes to C3b. And similarly, if I change another molecules, let's say this is the just like we can check by changing one. Now I will replace by 2. Let's say C, this is D. So for this case, how can I, if I rotate it, then I can rotate like this also. Let's say one is here C, another is here D, and one is in the front B, another is back B. So if I say this, so and front and back are same. This front and back are same, and one is cup is different, another this is different. Okay, so you see that. So this and these are same, and these are different. So here, which axis is present? If you say that axis, on that case, C3 is not there because these are different. And if I pass the C2, any chance C2? If I pass it, then pass it. No. So no C2 is there. So CN axis is not there. E is present, obviously. First is E. Then we have that sigma is there. Like if I cut that this and this, if I cut, then plane is passing through this and this, then this and this get reflected. So sigma is present. So this point group is lies in CS point groups. Okay, so if you make two difference, then this point group is same. And if I make this point with this and this are same, then what point groups you get? So let's say A, C, C. This is B and B. This actually looks. Let's say A and plane C. This is B and back is B. So here now I have to do the same. So if these and these are same and these are different, so this same and this and these are same. Okay, or maybe I do light. So these are same and these are same. So in that case, what axis is present? So if I pass this axis, C3 is absent. So now here, so here E is present. E is obviously present to everyone, and one plane we can pass that is sigma is there. Obviously sigma is there. If you cutting this get reflected, so sigma is there. And anything, C axis is not present, because if you cut this will go here, and if you cut this will go here. So for this, if are same, then is also here only CS axis is only present, because CN axis we will not get, because these, although these and these same, and these and these are same, and this same, but we can see that axis we are not getting anywhere. C3 is not same because these three are different, and C2. So for C2 we have to, C2 means 180 degree. So 180 degree if I rotate, then they will get, these are same but this is there, so this is make problem. So C2 is also not there, C3 is not there, C4 is not there because these are different, and C5 is not possible. So C axis is not there. This is also CS point groups. Okay, so I think that's right. So these are here also C axis is present, here also C axis point group is present. So now we will discuss another examples like cyclopropane. So cyclopropanes is like which type of structure? Cyclopropanes. So if I draw like this, so here HH, HH, HH. So here what thing? C3 axis is present. Passing through this C3 is present, and obviously 3C2 is present because if we pass this 3C2, and sigma H is present, and also we have what is there? Sigma H is there, and so C3 and sigma H is there, then S3 is there, and obviously 3 sigma B also there. So this is point groups that is in D3H point groups. So like this. So now in next class we will practice more. So today up to this. Thank you.